given that 3 inferences or inference about 2 means, and we're talking about independent samples. Okay. So assuming, again, we have a lot of assumptions here, we're talking about independent samples. So assumptions: 1, independent samples. And number 2, we have simple random samples used, and N1 and N2 to collect samples, N1 from population 1 and N2 from population 2. And we have normally distributed populations, normally distributed populations, and or this happens. And of course, for independence, N1 is less than or equal to 0.05 of N1, and N2 is less than or equal to 0.05 N2. In that case, what are the possibilities now? What are we talking about? We're talking exactly about the same 3 options. When the null hypothesis says mu1 equals mu2 in all of them, and the options for the alternative are exactly the same as always. Mu1 does not equal mu2, so the 2 populations have different means. For this situation, I mean, the second option is 1 is less than the other. No, the mean of population 1 is less than the mean of population 2. And these are one-tailed tests, and this is a two-tailed test. Nothing different, exactly all the same. And now the test statistic will be this. So x2 hat minus x, sorry, it's x1. x1 hat minus x2 hat minus population means over the square root of S1 squared sample standard deviation squared over sample size, sample 2 standard deviation squared, or variance, in other words, divided by the sample size 2. If data have outliers, the hypothesis testing should not be used the way we do it here. Okay. So I only copied one example for you, and then we'll create the confidence interval for the difference of the mean, of the 2 means, and then we'll look at problems step by step in MyLabs Plus. Okay, so let's read the problem. Here we are trying to test a hypothesis between 2 population means. And we'll see which one it is, and we'll conduct the test as we normally do, exactly the same. In the Space Lab Life Sciences 2 payload, okay, 14 male rats were sent to space. Fine. Upon their return, the red blood cells mass in millimeters of the rats was determined. A control group of 14 was held under the same conditions, except for space flight, as the space rats. And their red blood cells mass was also determined when the space rats returned. So the project resulted in the data listed here. We have the data. Does the evidence suggest that the flight animals have a different red blood cell? So the keyword is different here. A red blood cell mass from that of the control animals at the alpha 0.05 level of significance. So please tell me, what are you going to test? So we are assuming they are independent samples, not one selected space rat was connected to a Earth rat in any way. There were samples, simple random samples used. The population is normally distributed. or this, but we only have 14 in each. And the population, the samples are less than 5% of the population. Okay, so the null and the alternative. Can anyone say anything? What is the alternative and what is the null? Anyone wants to give it a shot? Is it case 1, case 2, or case 3? Anyone? Case 1, 2, or 3?
1.
Very good. So mu1 equals mu2. Mu1 is different from mu2. Very good. That is indeed the test of hypothesis. So now let's enter the data. I already entered it. I had a few minutes. I entered it. I'll wait for you to enter it and I'll dictate it to you if you'd like. So tell me when you're ready to start with list L1 or any list you have available. $8.59, $8.64, $7.43, $7.21, $6.87, $7.89, $9.79, $6.85, $7, $8.80, $9.30, $8.03, $6.39, and $7.54. The control group, I already entered it in my list L2. Tell me if you're ready. Can I dictate it to you? $8.65, $6.99, $8.40, $9.66, $7.62, $7.44, $8.55, $8.70, $7.33, $8.58, $9.88, $9.94, $7.14, and $9.14. After you enter the data, let me know. We go to 2 sample t-test, number 4. 2 sample t-test. We have the data, so please highlight data. And we do have list L1 and list L2, I hope. Scroll down to mu1 not equal mu2. That's what we have. That's our test. That's our alternative. Let's say we do not do a pooled. The pooled here refers to degrees of freedom. So degrees of freedom for our calculations for the test statistic will be smallest n minus 1. Well, it happens they are both 14. So it's 14 minus 1 is 13 degrees of freedom. So you know me, I like to draw. And we will determine the p-value. And we will determine the t-statistic. T-statistic is negative 1.4368 with a p-value of 0.1627. And alpha was 0.05. Any conclusion? First of all, tell me if you got the same answers. Did anyone get the same answers? Can anyone confirm my numbers? Anyone?
I don't have the answers.
You don't have the answers because something happened with the calculator? You want me to do this again, or?
If you could do it again.
So which part? Do you have the data entered already?
No, I don't have it. I don't have it entered. But if you could do it again, I would like to see it.
Okay, so you want me to assume that you have the data from that point on, right? You know how to enter.
Yes, please.
Okay, so we go to tests and we scroll down to a 2-sample t-test, number 4, 2-sample t-test. So we press enter and we have 2 options, either data or stats. I did not calculate the stats like standard deviation and mean. So I want the calculator to do that by itself. So I will choose data, list L1, list L1, list L2. And then I choose the first option, mu1 does not equal mu2 because that's what I have. And I will choose not a pooled degree of freedom. The calculator will calculate more exact. You can choose. You can choose yes if you want. But it will calculate the more exact degrees of freedom. And I want to draw, and it draws, and it gives the p-value and the z-statistic. And I copy them here. The t-statistic is negative 1.4368, degrees of freedom 13, and the p-value is 0.1627. And now the question is, conclusion. What do we conclude? Can anyone tell us? And then we'll determine the confidence interval, 95% confidence interval. So what is our conclusion then? Anyone? Can anyone help with the conclusion? Okay, so let's discuss that. It's okay. So if the p-value is greater than alpha, we fail to reject. If the p-value is less than alpha, we reject. So then, which one is it? Correct, because the p-value is 0.16 and alpha is 0.05. Very good. So p-value is greater than alpha, fail to reject H naught. So we write this. There is insufficient evidence coming from this sample, coming from this sample. There is insufficient evidence to conclude that mu1 different than mu2. So we will say it appears that there is no difference. They have the same blood cell, red cell count. The ones coming from space, having a trip, made a trip in space, and the other ones that have not. Now we're also asked to find, for the same problem, we're asked to find a 95% confidence interval. Okay, so let's go to stats again. We have the data. Go to tests. And this is a two sample t interval. 0. 2 sample t int. Okay, we have the data, we have everything. That's it. Everything is there, calculate. So that is negative 1.335 to 0.23655. So this is our confidence interval. As you see, it consists, or it has negative values and positive values, which means it has 0. 0 is between the lower limit of the interval and the upper limit of the interval, which is consistent with what we found. If it were only negative, we would have said that mu2 is greater. If it only were positive, we would have said mu1 is definitely greater. But because there is 0 in the interval, we don't know. Sometimes it's this way, sometimes it's this way, so we cannot conclude that there is any difference. Significant difference. Okay,